Hi everybody, welcome to another video in Pre-Calculus, section 7.3, Law of Cosines. So in the previous section we have the law of sine, and we use the law of sine when we have a pair of opposite angle in sine. So when we cannot use the law of sine, then of course we will use the law of cosine. So the law of cosine states that the square of one side of a triangle equals the sum of the squares of the other two sides minus twice their product times the cosine of the angle between the two sides. Right. So, by the way, if we don't have that part, that is Pythagorean theorem, right? Now, remember, this theorem works for any triangle. So we don't have the 90 degrees angle anymore. So in the general triangle, like this, and let's just look at the middle one then. So we start with b square is equal to c square and a square. So if we have a square of one side is equal to the sum of the square of the other two. So if we look at b, then we're going to have c square and a square, and then minus a and c. So those two letters will be the same as those two letters, and the cosine of the angle in between them. So if it is b, end up with angle b. If it is a, end up with angle a. And if it's c, end up with angle c. So straightforward. So just that. Of course, on the special case when c is equal to 90 degrees, which is the right angle, cosine of 90 degrees is equal to 0. So that equal to 0, and we have Pythagorean theorem when the angle is 90 degrees. So that still works. So the law of cosine is a lot more general case of the Pythagorean theorem. Right, now, most important, when do we use the law of cosine? Well, I did mention that before, where we cannot use the law of sine. So pretty much use law of cosine where we cannot use the law of sine, pretty much. Of course, in particular, we use the law of cosine when we do not know a pair of opposite sine and angle. If we do know a pair of opposite sine and angle, use the law of sine. If we don't know, use the law of cosine. Right. We don't. Of course, let's just draw the sketch later, draw the summary, draw a table first. So in the first example, we don't know angle A or angle B. We know C though, 50 degrees. Right, we know A is 4, B is 5, and sine C we don't know. Right, so we only know one angle, so we cannot find the other two yet. So add up them up to 180 doesn't help us to find A and B. Right, so here we don't have the pair of opposite sine and angle, right? Because of that, we have to use law of cosine here. And there are three law of cosine. Which one do we use? Well, that's easy. We have the angle C, so we choose the one with angle C. Therefore, we know use the one that starts with the sign little c. So, law of cosine here. use law of cosine. So what do we have here? Of course, we're going to use the one that starts with c. So we have c squared equal to a squared plus b squared minus 2ab cosine of c. Right, we know everything on the right hand side. So we have c squared equal to a squared b squared minus 2ab cosine of 50 degrees. Right. Most important, when we solve triangle, make sure it is in the degree mode. Right, degree mode, which is good. Right, 4 square plus 5 square minus 2 times 4 times 5 times cosine of 50 degrees. So we have 15.288 something, right? 15.288. Right, now take the square root on both sides. Typically it's plus or minus, but we don't need that here because in a triangle the measurement must be positive. So that is 15.288. 15.288. So c is equal to square root of 15.288. So I have square root of that, 3.91. Right. Right. Next we have a pair of opposite sine angle. We can find this angle, right? Okay. So, and also when we know all the sides, we can find the angle as well. So in here we have option to use law of cosine or law of sine, but I will go with law of sine here because I have the pair of opposite sine angle. Right, so let's just write out sine of angle A, don't know that, divide by little a, sine of angle B, divide by little b, and sine of A divided by 4, sine B divided by 5, and sine of 50 degrees. For 3.91. Right. Yeah. We do know B, little b is 5, right? Right. Now, just take a ratio, and then here we can solve for sine B, and then inverse we have B, right? Right. Sine of B, of course, equal to 5 times that, divided by 5 sine of 50 degrees, divided by 3.91. 5 sine of 50 degrees, divided by that number. Sorry, just make sure that is still in degree mode. Right. 0.9796. Right, to get back to the angle, we will take the inverse. Of course, inside there's a supplement as well. So there's a drawback where we use the law of sine to find the angle. We always have to worry about the supplement case. So, and sine inverse 78.4 degrees. that is B, right? Of course, it can be also be the supplement to this. When we use the law of sine to find the angle, it's always potentially be this situation. So we take 180 minus that. Have 101.6 degree. Alright, which one is that? Now we know B is the facing the longest side, so that must be the biggest angle. So, but that both of them look right. Well, we'll see. Right. Now let's check the first and the last ratio, and also cross multiply. And solve for sine A. For sine 50 degrees over 3.91. Right. 4 times sine of 50 degrees divided by, do we have 3.91? Yep, this one. And we have 0.78 something. Right. Once again, to get to A, we have the sine inverse. Or the supplement to that. Sine inverse 51.6 degree. Now think about this. Of course, let's just find the other one. Think about that later. 180 minus that 128.4. So which one is right now? I think about this. Angle A cannot be the biggest angle because sine A is not the longest side. So if A is equal to 128.4, that is the biggest angle. Cannot be that case because angle A do not face the longest side, so it cannot be the biggest angle. So this one is not right because angle A cannot be the biggest angle. So we have A is equal to 51.6. And then because we know the others. So the order have to be 78.4. Because we just subtract from 180. Yeah. So even though we have two answers, of course, we can do the other case to find it out. That is 78.4. So that's good, right? So the point here is whenever we use the law of sine to find the angle, there is the supplement. So potentially there are two solutions, which is not ideal. However, if we know that it is not the biggest angle, because when we look at this, look at the length, the size here, if we know that it is not the biggest angle, then it's only one solution. It cannot be an obtuse angle, right? Obtuse angle must be the biggest angle. But if we know that it is not the biggest angle, so it cannot be obtuse. Having said with that, whenever we use the law of sine to find the angle, we do not want to use law of sine to find the biggest angle. We want to use the law of sine to find the smaller angle. So in that case, we don't have to worry about the supplement. Right. So so to keep that little note in mind. Preferably, don't use law of sine to find the biggest angle. Use law of sine to find the other angles. That may help. Right. We'll do the next example here. This triangle, we only know all about the sides, don't have any angle. So, of course, we use the law of cosine here because we cannot use the law of sine. Don't have the opposite angle and sine here. So, law of cosine, the only option here. There are three of them. So, which one do we use? Now, let's go back to the problem. We're trying to find an angle here, right? And I just mentioned before, preferably, we don't want to use the law of sine to find the biggest angle. Don't use the law of sine to find the biggest angle because potentially that could be the supplement. So if we don't want to use the law of sine for the biggest angle, so if we have to find the angle, use the law of cosine, just go with the biggest one first, and then later on we use law of sine. Those have to be a smaller angle, right? So go with the biggest angle, because when we do that, we take care of the biggest angle. Everything after that must be acute. Everything after that must be less than 90 degrees. So we don't have to worry about the supplement case. Right. Of course, the biggest angle should be C. So we go with the one that has the angle C. Of course, do the first one. C square equal to A square plus B square minus 2AB cosine C. Right, so we know everything but the angle C. So we can say cosine C equal to, step by step. Subtract A square and B square to the other side. And then divide by negative 2AB. C square minus A square minus B square over negative 2AB. Right. C square 13 square minus A 4 square minus B square 8 square minus 2AB. Right. On the top, 13 square minus 4 square minus 8 square divided by negative 2 times 4 times 8. Right, this is negative 1.39, right? And then for cosine, to get back to the angle, remember cosine we have the cosine inverse, right? Or negative. Sine is supplement, cosine is opposite. But in either case, it is no solution because cosine has to be between negative 1 and 1. So we will take cosine inverse of that. It's undefined, right? So this one is no solution. That's why I only leave that much space for this problem. No solution. Right. Now, go to this example. Once again, this, forgot to mention. On the previous case, what we have here is we have the sine A, we have the sine B, and that is sine B, and of course the angle C. So this scenario we have angle between the two sides, so that is sine angle between the two sides, which gives us a unique solution. Right, this of course obviously we have three sides, so this is sine, 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 but the reason this is no solution because we have one side that is extremely long, 13, one of them is 4, and the other one is 8. It's not long enough to form the triangle. Also, we have from the first section, from the first part of the section, we have, the first part of section 7.2, triangle inequality, the sum of two sides must be longer than the third side. So the other two sides have to be long enough to form a triangle, which in this case they do not. So that's why it's no solution. Right, now in this case also sine, 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 and we can check 5 plus 4 greater than 7. Pretty much we take two of them, add together, is bigger than the other one. So this should be a solution here. Right. Write a summary. We know all the sides. A is 5, B is 4, and little c is 7. We do not know any side, do not know any angle. Right, because we do not know any angle, we cannot use the law of sine, because we require to have a pair of opposite side angle, which we don't have. So I have to use law of cosine here. So which one do we use? Well, of course, any one of them will work, but just like the last problem, we want to use the law of cosine to take care of the biggest angle first. After that, it's easy. Law of sine would be a lot easier. And also, when we use the law of cosine to find the angle, we will never consider the case of the negative. The angle cannot be negative in a triangle, right? Right, law of cosine. So we have to use the one with the biggest angle, which is angle C. So we start from c squared, a squared plus b squared minus 2ab cosine c. So subtract a squared and b squared, we have negative 2ab cosine c. And to solve for c, cosine c, we have c squared minus a squared minus b squared over minus 2ab. Right. 7 squared for c squared A is 5 and B 4. Negative 2 times 5 times 4. Right, just do that and then take inverse, find the angle. Simple enough. So we have 7 square minus 5 square minus 4 square divided by negative 2 times 5 times 4. And then we take the inverse. Once again, when we take the inverse, make sure that it's in the degree mode. Pretty much in this section, when we're trying to solve for the angle in the triangle, make sure we keep in degree mode because that's what the angle is in. So cosine inverse of that, 101.5 so C equal to cosine inverse of negative 0.2, 101.5 degrees. So, and then the rest will be easy. We find angle B and angle A using law of sine because we have the pair of opposite sine angle here. Or we can use the law of cosine. Let's use law of cosine. Actually, law of cosine could be a better idea here because if we use all of this to find angle, that would be best because we use the numbers that is the numbers that are given. We do not use the one that is rounded off. Right. So again, we keep rolling with law of cosine, but this time let's go with b squared equal to a squared plus c squared minus 2ac cosine b. Alright. And then to solve for cosine b, subtract the other two and divide by negative 2ac. So we have cosine of b squared minus a squared minus c squared for negative 2ac. Let's continue over here. Cosine of b is equal to b squared minus a squared minus c squared over negative 2 a c. I just take cosine inverse. Now let's do that first. On the top, 4 square minus 5 square minus 7 square divided by negative 2 times 5 times 7. Like that. And then when we find angle B, we just find the cosine inverse. Notice that we do not need to do the opposite because angle must be positive. Cosine inverse of that, 34 degrees. Of course, we can subtract from 180 and that's it, right? But of course, we can also use the law of cosine, still doing that. Start with a squared equal to b squared plus c squared minus 2bc cosine a, and then we solve for cosine a, and then inverse of that get us back to angle A. But here's, we just take 180, subtract the other two angle. It is not the direct way, but we have the good enough answer, 44.4. So if we use the law of cosine, something similar to this, but start with a squared equal to b squared plus c squared minus 2bc cosine a, then find a, should get 44.4. Right, so that's what we have. So for the sine scenarios where we use the law of cosine to find angles, take care of the biggest angle first, and after that it's easy. We can use either law of sine or law of cosine. Of course, if we want to use the law of sine to find 8, let's just do that. It's a way to check it, right? So sine of angle A, which we don't know, divide by 5 equal to sine of 34 degrees over 4, right? So in this case, sine A equal to 5 sine of 34 degrees divided by 4. So 5 times sine of 34 degrees divided by 4. Like that. To get A, we just do this sine inverse of whatever we have there. And we don't have to worry about the supplement, because this is not the biggest angle. The angle must be acute, so there will be no supplement here. Because we should have about 44.4 degrees. Yeah, so that's good. Of course, the reason is it's not work perfectly because we didn't round off perfectly. But that's what we have, right? So there's a lot of options. But if we want to use the law of cosine to find angle, go with the biggest angle first. The rest easy. Law of sine or law of cosine. We'll have that. Right. Now we have an application here. Motorized boat leaves Naples, Florida, go for Key West, 150 miles away. So that is 150 miles away. But it encountered maintaining a speed of 15 miles per hour, but encountering a heavy crosswind and strong current. The crew found out after 4 hours. Of course, that's where it travels 4 hours at 15 miles. I should say 15 miles per hour for 4 hours. Of course, that gives us 60 miles, right? So, because of the crosswind, it flowed that direction. It go in this direction instead, 60 miles that direction, as opposed to we need to go 150 this way. Right. And we know that it is off course by 20 degrees, so we have the angle in between is 20 degrees. Oh, they set the angle A, so this is A. So this is B and C. Right. So instead of we want to go straight from B to C, but we couldn't. The wind blow it that way, and so we after 5 hours we stop at A first. Now, first question is, how far is the sailboat from Key West at that time? So from A to C, what is that? Next, through what angle should the sailboat turn to correct the course? So if it just keep going, it will be in that direction, but it have to turn and go to direction to C. And how much time added to the trip because of this? Assume the constant speed of 15 miles per hour, and also assume that the affecting at first by the wind is only for the first 4 hours. After that, there's absolutely no wind. Like that, perfect condition. So we can just write straight there. Right. So we have A, B, and C. So let's just write a summary of the problem. So what do we have for this problem? This is a triangle ABC, right? Opposite to angle A is sine A. Opposite to angle C is sine C. So we do know A and C. We know the angle B is 20 degrees. We know A is 150. And we know C is 60. Of course, 4 hours at 15 miles per hour, that travels 60 miles. Of course, now the question, how far is the sailboat from Key West, which is the distance AC? So first, the first part of the question asks for the distance AC with opposite to B, so which is B. So the answer is going to be B. Yeah, the distance from the sailboat to Key West at that time. Next, to what angle should the sailboat turn to correct the course? Right. So we need to find angle theta here. But angle theta with angle A, those combined together is a straight angle. So that add up to 180 degrees. So theta is 180 minus angle A, right? Because they combine together is 180 degrees angle. So in that case, we need, I don't know why I put B there. We need to find A first. Once we know A, we can find theta. And then finally, how much time has added to the trip because of this. So notice that when we do this, we do not need to find angle C, right? So just need A and B. And then the last part, we determine that later. Right. Now, once again, do not have a pair of opposite sine angle. So this must be law of cosine. And we have angle B, so we have to start with the sine B. B square equal to A square plus C square minus 2AC cosine B. Let's just put all the numbers in. We have everything, right? A 150 square plus C 60 square minus 2 times 150 times 60 times cosine of 20 degrees. Still degree more. Yep. 150 square plus 60 square minus 2 times 150 times 60 times cosine of 20 degrees. Remember that. Of course, that's not the answer. That's not B, right? This is B square. So we just take square root of that. So 95. So that sounds reasonable. $95.8 miles. Right, that's reasonable. This is 60, that is 95.8, a little bit. When they add up, it's more than 150, of course. So that is correct there. I mean, add these two, it is more than 150. So that will form a triangle, which is good. Next, to get angle A, to find angle A. Well, how do we do that? Of course, we can use the law of sine. When we know this, we use law of cosine. I prefer to use the law of cosine where we have all of the signs here, because the law of cosine, when we take cosine inverse, that is the only angle we have. So use the law of cosine to find A. So since we find angle A, we start with sine A. Right. So A square subtract B square subtract C square equal to negative 2BC cosine A. So cosine A equal A square minus B square minus C square over negative 2BC. Right. So we have the numbers. A square 150 square minus 95.8 square minus 60 square over negative 2. B 95.8, C 60. Alright, so we do that. On the top, 150 square, subtract that number square, subtract 60 square, divided by negative 2 times that number times 60. And with that, and then we take the inverse cosine. Have the angle A. Cosine inverse of whatever this is. 0.84745. Sorry. Yeah. When we use the law of cosine to find the angle, it's straightforward. 147.6 degrees. Look reasonable. So that is the biggest angle we face the longest side. That's for sure. Right. Now, of course, the question is not asking for angle A. Angle A is here. So we subtract from 180. So that gives us the adjustment that we have to change course. So we can go straight to Key West. So we take 180 minus this, give us theta. And take 180 minus that. We have 32.4 degrees. So that answers the second question. So the first part of the question, from at that moment to Key West, that would be 95.8 miles more. But in order to go to Key West and to the direct direction, we have to turn an angle 32.4 degrees. And how much time has been added to the trip because of this? Well, originally we spent 4 hours. So from A to B, from B to A, we spent 4 hours already. And that's 60 miles, the first 60 miles. And then after that, from A to C, we know the distance is 95.8 miles. At this constant speed of 15 miles per hour, so we take that number. What's that number? Okay, this divide by 15. So that's about 6.389. So we take that divided by 15 miles per hour give us 6.389 hour. So from B to A 4 hours, from A to C is that much. When we add them, so the total travel time is equal to 10 hours, 10.39 hours. Right, so it takes 10 hours and 0.389. Of course, if we want to, we can convert this. His second angle convert to degree, minutes, and second. So 10 hours, 23 minutes, 22 seconds. Right, so that takes that much time. However, if we go straight from B to C, that's 150 miles, 15 miles per hour. So if we go straight, that will take 10 hours. But because of the up course here, we have an extra 23 minutes. Right? So the total time is this. Of course, subtract the ideal time. Ideal time is 15 miles per hour for 150 miles. So ideal time is 10 hours. Subtract them, we have 23.389 something, and that is 23 minutes. So because of that, it takes an extra 23 minutes and 22 seconds to go to A and then go to C. Right. Now, with that, I finish. Finish the section here. As always, see you in another video in pre-calculus. Thank you for watching.